Tonight, we're traveling back to a version of Earth no human ever witnessed. A world of endless oceans, giant forests, ancient monsters, and frozen planets drifting through deep time long before civilization ever existed. Welcome to Sleepy Earth Channel. So get comfortable, relax, and let's explore what Earth truly looked like before humanity arrived. And before we begin, leave a comment below telling me what city you're watching from tonight. Long before the first human voice echoed across a valley, before the first fire was lit beneath a dark sky, before cities, ships, languages, or memory itself, Earth already had a history so vast that the entire story of humanity would eventually occupy only the final fraction of a second. For most of this planet's existence, there was nobody here to witness anything. No eyes watching the oceans rise, no hands drawing maps, no names for mountains, storms, or stars. The world existed in complete indifference to the creatures that would someday try to explain it. And if you could somehow stand on that ancient Earth billions of years ago, the first thing you would probably notice is not how unfamiliar it looked, but how alive it already seemed without us. The silence would feel enormous, not empty, but ancient. The kind of silence created by a world that had never heard language before. The continents would not resemble anything hanging on a classroom wall today. Entire land masses drifted across the planet like slow-moving rafts over unimaginable spans of time, colliding and separating again and again, long before human history ever began. Some scientists believe the earliest continents may have looked almost alien compared to modern Earth. Dark volcanic surfaces surrounded by violent oceans, beneath a sky thick with gases no human could breathe. There were no forests then, no birds, no grass moving in the wind. Even the colors of the world may have been different. The oceans themselves might have carried a greenish tint because of dissolved iron, while the atmosphere glowed beneath clouds of methane, carbon dioxide, sulfur, and volcanic ash. Sunlight filtered through this unstable sky in strange ways, illuminating a planet still cooling from its own creation. And above it all hung a moon that appeared far larger than the one we know tonight. Because billions of years ago, the moon orbited much closer to Earth than it does now. Some researchers estimate it may have looked several times larger in the sky, dominating the horizon with terrifying brightness. Its gravity pulled violently at Earth's oceans, generating tides far more extreme than modern coastlines experience today. Entire shorelines could flood and retreat with staggering force. The planet was not calm. It was still becoming itself. In those distant ages, Earth may have resembled less of a peaceful blue world and more of a restless furnace wrapped in storms. Volcanoes erupted continuously across the young planet, releasing gases trapped deep inside the crust. Rivers of lava stretched toward the horizon beneath blackened skies, while enormous impacts from asteroids and comets scarred the surface over and over again. Some of those collisions were powerful enough to boil parts of the oceans or melt sections of the crust itself. Yet, strangely, many scientists also suspect those same impacts may have delivered some of the water and chemical ingredients that eventually helped life emerge. In other words, destruction and creation may have been happening simultaneously from the very beginning. That possibility changes the way the early Earth feels. The chaos no longer seems random. It starts to resemble preparation. Even now, researchers still debate exactly how the first oceans formed. One theory suggests water vapor released by volcanic eruptions slowly condensed as the planet cooled, creating rain that may have fallen for thousands or even millions of years. Another proposes that icy comets bombarded the Earth during its early formation, bringing water from deeper regions of the solar system. There may never be a single simple answer, but eventually, somehow, enough water gathered to cover most of the planet. And once that happened, Earth became something rare, maybe extraordinarily rare. A rocky world with stable liquid oceans orbiting within a narrow zone around a star. From space, it would have looked almost peaceful, but standing on its surface would have told a very different story. The air itself was toxic. Oxygen, the gas modern animals depend on every second, barely existed. Instead, the atmosphere was dominated by gases that would quickly kill a human being. Lightning storms moved across the horizon over oceans that may have reached temperatures far hotter than today's seas. Some scientists imagine coastlines filled with black volcanic rock where steam rose constantly into the sky. Others believe giant impacts kept interrupting any long periods of stability. Either way, this was not a world designed for us. And yet, paradoxically, it was the only world that would ever produce us. That contradiction sits quietly beneath the entire history of Earth. Humanity often imagines the planet as if it were always preparing specifically for human civilization. But the deeper scientists study geological time, the stranger that assumption begins to feel. If Earth's history were compressed into a single day, modern humans would appear only seconds before midnight. Dinosaurs vanished long before that. Complex life dominated oceans for ages before dinosaurs even existed. And for billions of years, the planet belonged only to microbes and microscopic organisms invisible to the naked eye. The overwhelming majority of Earth's story unfolded without a single human thought anywhere on the surface. Sometimes it becomes difficult to truly imagine those stretches of time. Human history feels ancient to us because civilizations rise and disappear over mere thousands of years. But geological time operates almost beyond intuition. Entire mountain ranges rose and eroded away before the first mammals evolved. Oceans opened and vanished completely. Climates transformed the entire appearance of the planet again and again. Antarctica, now buried beneath ice, may once have supported forests filled with ancient life. Deserts that look eternal today were once underwater. Areas now submerged beneath the sea once carried rivers, valleys, and perhaps entire ecosystems lost forever beneath modern coastlines. The Earth before humanity was not one stable world. It was countless different worlds layered on top of each other across time. And every version of Earth would have felt permanent to the creatures living there. There is something unsettling about that realization, because from the perspective of deep time, permanence itself becomes an illusion. Even the stars above the ancient Earth looked slightly different. The moon slowly drifted farther away year after year. Days were shorter in the distant past because Earth rotated faster. Hundreds of millions of years ago, a full day may have lasted around 22 hours rather than 24. Tides behaved differently. Seasons shifted differently. Some researchers even suggest ancient skies may have appeared hazier because of atmospheric conditions unlike anything modern humans have experienced. If a traveler from today suddenly stepped into one of those ancient landscapes, the planet might still be recognizable as Earth, but only barely. Familiar enough to create awe, different enough to create fear. And perhaps the strangest part of all is that none of it required human observation to exist. Forests spread without witnesses. Oceans crashed against empty shores for millions of years before anything listened. Lightning illuminated continents where no eyes watched the storms. The Earth did not wait for consciousness to arrive before becoming beautiful. In fact, some scientists and philosophers quietly wonder whether the planet may have been at its most pristine precisely because humans had not yet appeared. Gigantic migrations crossed untouched plains. Rivers carved valleys uninterrupted by roads or dams. Entire ecosystems expanded according to ancient patterns shaped only by climate, geography, and evolution. But that world was never peaceful in the modern sense either. Predation, extinction, volcanic disasters, asteroid impacts, climate collapse. These forces shaped Earth long before humanity existed. Nature was not gentle. It was simply indifferent. And that indifference may be one of the most difficult truths hidden inside the ancient world. Species emerged, flourished, and vanished continuously. More than 99% of all species that have ever existed are now extinct. Entire branches of life disappeared forever, leaving behind only fragments buried in stone. Sometimes, a sudden catastrophe ended them. Sometimes, environmental changes slowly pushed them toward extinction over millions of years. The Earth before humans was not a stable paradise. It was an experiment unfolding endlessly across time. Yet despite all that instability, life continued adapting. Again and again. After every collapse, something survived. Tiny organisms endured conditions that seem impossible by modern standards. Creatures evolved in boiling seas near volcanic vents. Others survived beneath ice-covered oceans during global freezes. Life occupied darkness, poison, crushing pressure, and extremes of temperature. Looking backward across those unimaginable eras, the history of Earth begins to feel less like a straight path leading inevitably toward humanity, and more like a chain of improbable survivals balanced against enormous odds. Perhaps that is why ancient Earth feels so mysterious even now. The deeper science explores the past, the more the world before humans seems both familiar and unreachable at the same time. We walk across landscapes shaped by ancient catastrophes we never witnessed. We breathe oxygen produced partly because microscopic organisms transformed the atmosphere billions of years ago. The ground beneath modern cities contains the compressed remains of forests older than dinosaurs. Entire chapters of Earth's history survive invisibly beneath our feet, hidden in rock layers that record vanished oceans, extinct creatures, and climates no human civilization has ever experienced. And somewhere inside all of that deep history lies a strange realization. For most of Earth's existence, nobody knew the planet existed at all. The oceans moved in darkness beneath silent skies. Continents drifted without names. Mountains rose without maps. The Earth simply turned through space alone, carrying within it the possibility of humanity long before humanity could ever imagine the planet in return. There was a time when Earth did not resemble a living world at all. No forests stretched across continents. No animals moved through shadows. No birds crossed the sky. The planet was still raw, unstable, and violent in ways almost impossible to compare to the modern world. If you could stand on the surface during those distant ages, somewhere more than 4 billion years ago, the earth beneath your feet would not feel ancient yet. It would feel unfinished. Entire regions of the planet glowed with volcanic heat. Rivers of lava cut through blackened terrain, while enormous plumes of ash climbed into an atmosphere thick with toxic gases. The ground itself cracked constantly as heat escaped from deep within the young planet. Nothing stayed calm for long. Even the oceans, which now make Earth seem peaceful from space, may once have looked dark, steaming, and hostile beneath a sky without blue. Scientists sometimes describe this era as the Hadean Aeon, named after Hades, the ancient Greek underworld. And strangely, the name still feels appropriate. Earth may have looked closer to a vision of hell than to the planet humans would someday call home. Yet hidden inside that chaos was the beginning of everything that came later. The early Earth formed from violent collisions inside the young solar system, where dust, rock, and ice circled the newborn sun in enormous clouds. Over time, gravity pulled those fragments together into larger and larger bodies, until eventually a growing planet emerged. But formation was not a gentle process. Each collision released staggering amounts of energy. Some impacts were so massive they melted huge portions of Earth's surface entirely. For long periods, scientists believe the young planet may have been covered by vast oceans of molten rock. Imagine looking across the horizon and seeing not water, forests, or mountains, but glowing magma stretching beneath clouds of smoke and ash. The Earth itself radiated heat into space like a giant furnace. And then, something happened that changed the future of the planet forever. At some point early in Earth's history, a Mars-sized object may have collided with the planet in an event so catastrophic it reshaped both worlds instantly. Scientists call the hypothetical object Theia. According to the leading theory, the collision blasted enormous amounts of debris into orbit around Earth, where it eventually formed the moon. If that theory is correct, then the moon itself may have been born from one of the most violent impacts in the history of the solar system. For a while, the skies above Earth would have looked terrifying beyond imagination. Fragments of molten rock may have circled overhead like glowing storms, while the surface below remained partially melted from the collision. Some researchers suspect entire oceans vaporized temporarily during this period. Others believe parts of Earth cooled faster than expected between repeated impacts. The exact timeline is still debated, and many details remain uncertain. But what seems clear is that the young Earth survived repeated catastrophes that should have destroyed stability entirely. And somehow, eventually, stability began to emerge from destruction. As the planet slowly cooled, water vapor trapped in the atmosphere condensed into rain. But this was not ordinary rain falling over quiet landscapes. Some scientists think storms may have lasted continuously for thousands or even millions of years. Rain poured onto volcanic terrain, already boiling from internal heat. Steam rose everywhere. Lightning flashed endlessly through thick clouds, while asteroid impacts occasionally interrupted whatever fragile balance had formed. There is even debate about how much of Earth's water truly came from within the planet itself. Some evidence suggests volcanic outgassing released massive amounts of water vapor over time. Other research points toward icy asteroids and comets delivering additional water from farther regions of the solar system. It may have been both. The oceans humans know today could partly be the result of ancient cosmic debris colliding with Earth billions of years ago. That possibility changes the feeling of the oceans entirely. Every wave begins to seem connected to events older than the continents themselves. But even after liquid water gathered across much of the surface, Earth remained profoundly dangerous. The atmosphere contained almost no oxygen. Instead, gases like methane, carbon dioxide, ammonia, and sulfur compounds dominated the sky. Breathing there would have been impossible for modern humans. The sunlight itself may have looked different because the atmosphere filtered light in unfamiliar ways. Some researchers suspect the sky may have carried an orange or reddish hue at certain times. Others argue thick volcanic haze would have darkened much of the planet intermittently. There are still major uncertainties because no direct record survives from those earliest ages. Much of Earth's oldest crust has been recycled deep into the mantle through plate tectonics over billions of years. In a strange way, the planet erased much of its own childhood, yet traces remain hidden in ancient minerals called zircons, tiny crystals older than almost anything else on Earth. Some of these microscopic fragments suggest liquid water existed surprisingly early, perhaps sooner than scientists once believed possible. That discovery changed the story dramatically. It hinted that even during periods of chaos, parts of Earth may already have been cooling enough for oceans to form. And where there are oceans, new questions immediately appear, because water changes everything. Water absorbs heat. Water reshapes rock. water creates chemical environments where increasingly complex reactions become possible. Some scientists suspect shallow pools near volcanic regions may have become natural laboratories where the ingredients of life slowly assembled. Others believe the origins of life began far below the surface in deep-sea hydrothermal vents, where superheated water, rich in minerals, erupted from cracks in the ocean floor. Those underwater regions still exist today, hidden in darkness beneath immense pressure. Strange ecosystems survive there without sunlight, feeding instead on chemical energy rising from Earth's interior. Looking at them now feels almost like looking backward through time. Because life on Earth may have first emerged in places very similar to those ancient environments. But at this stage of the planet's history, life itself may not have existed yet. Earth was still balancing between lifeless chemistry and biological possibility. And during that balance, the world must have felt astonishingly alien. There were no trees softening the landscape, no oxygen-rich winds, no soil in the modern sense. The continents themselves may have looked mostly barren, dark volcanic masses rising above immense oceans. Some researchers think tectonic activity operated differently back then because the planet retained more internal heat. The crust may have been thinner, weaker, and more unstable. Volcanoes likely erupted on scales difficult to compare with modern events. Entire regions may have been resurfaced repeatedly by lava. Even the tides were more extreme because the moon orbited much closer to Earth. Coastlines flooded and retreated with incredible force. Days were shorter, too. The Earth rotated faster during its youth, meaning sunsets and sunrises arrived more quickly than they do now. Time itself behaved differently on the ancient planet. And above all of it hung the sun, strangely dimmer than it is today. This creates one of the most fascinating puzzles in Earth science. According to standard models, the young sun produced significantly less energy billions of years ago. Yet, geological evidence suggests liquid oceans still existed on Earth instead of freezing solid. Scientists call this the faint young sun paradox. To explain it, some researchers propose greenhouse gases trapped more heat in the atmosphere. Others suggest cloud patterns, ocean chemistry, or geothermal heat played larger roles than previously understood. No single explanation fully solves the mystery yet, which means one of the most important questions about early Earth remains partially unanswered. Somehow, despite weaker sunlight and endless violence, the planet avoided becoming permanently frozen or permanently molten. It remained balanced in a narrow and unstable middle ground where oceans survived. That balance may have been extraordinarily fragile. If certain conditions had shifted slightly differently, Earth might never have become habitable at all. Venus, often called Earth's twin because of its similar size, evolved into a world hot enough to melt lead beneath crushing atmospheric pressure. Mars, meanwhile, lost much of its atmosphere and surface water, becoming cold and dry. Earth somehow escaped both extremes. Why exactly that happened is still debated. Some scientists emphasize plate tectonics regulating carbon dioxide levels over immense timescales. Others, point to the stabilizing influence of the Moon on Earth's rotation and climate. There may not have been one single reason. It could simply be that Earth occupied an incredibly rare chain of circumstances that happened to remain stable long enough for life to emerge. And maybe that is the strangest part of this ancient era, because despite all the fire, poison, impacts, and darkness, the young Earth was not failing. It was becoming. Every eruption helped shape the atmosphere. Every storm altered the oceans. Every collision redistributed minerals and energy across the planet. The chaos was not separate from the future of life. It was part of the process that made life possible in the first place. Looking back now, billions of years later, the ancient Earth begins to feel less like a dead world and more like a restless machine, building conditions it did not yet understand. The fire and oceans were already interacting in ways that would eventually transform the entire planet forever. And somewhere beneath those black, volcanic skies and boiling seas, hidden inside chemical reactions too small for any eye to witness, the boundary between lifeless matter and living systems may have already been beginning to blur. For an unimaginably long time, Earth remained a world of stone, water, heat, and chemistry. Oceans moved beneath dark skies, while volcanoes reshaped the surface again and again. Yet nothing truly lived. There were no predators hunting through shadows, no plants reaching toward sunlight, no sounds except wind, thunder, crashing waves, and the deep, violent machinery of the planet itself. And then, somewhere inside that enormous silence, something changed so profoundly that every creature alive today is still part of its consequence. At some point, billions of years ago, matter on Earth stopped behaving like ordinary chemistry and began behaving like life. Nobody knows the exact moment it happened. There is no fossil showing the first living cell opening its membrane for the first time. No preserved record explains when lifeless molecules crossed the invisible boundary into biology. But somehow, in a world that still looked hostile beyond imagination, the first living systems appeared. And strangely, most scientists no longer think this happened beneath sunlight at all. Increasingly, many suspect life may have begun in darkness, deep beneath the ancient oceans, far below storms and volcanic coastlines. The seafloor itself was tearing open. Cracks in Earth's crust released superheated water, rich with minerals and chemicals from the planet's interior. These hydrothermal vents created strange underwater towers surrounded by clouds of dark, mineral-rich fluid. Even today, these places look almost alien. No sunlight reaches them. The pressure would crush a human instantly. Temperatures near the vents can become hot enough to melt lead, while surrounding waters remain near freezing. And yet, life thrives there. Entire ecosystems survive without sunlight, feeding instead on chemical energy rising from inside the Earth itself. giant tube worms, ghostly crabs, strange bacteria, all living in total darkness. Looking at these environments now, scientists sometimes feel they are seeing echoes of the ancient world where life first began. Because hydrothermal vents naturally create energy gradients, mineral surfaces, and chemical reactions that may have helped simple molecules organize into increasingly complex structures. In some ways, the seafloor itself may have acted like a giant planetary laboratory. But the mystery becomes even stranger the deeper researchers look. Life is not merely complicated chemistry. Even the simplest cell performs astonishingly complex tasks. It stores information, reproduces, repairs itself, adapts to environments, and maintains order against the constant tendency of the universe toward disorder. The question is not simply how chemicals existed on early Earth. The question is how those chemicals began cooperating in ways that created self-sustaining systems. And despite decades of research, scientists still debate the answer intensely. One possibility is that life began in shallow pools near volcanic regions, where cycles of evaporation and rainfall concentrated organic molecules over time. Lightning may have triggered chemical reactions in the atmosphere, producing amino acids and other building blocks that accumulated in these ancient waters. This idea became famous after experiments in the 1950s showed that simulated early Earth conditions could naturally generate some of the molecules associated with life. Suddenly, the emergence of biology no longer seemed impossible. It started to feel chemically plausible. But plausible is not the same as solved. Creating amino acids is still very different from creating living cells. Other researchers believe life may have originated around hydrothermal vents instead, where mineral-rich environments offered more stable conditions and constant energy sources. Some even propose that the first biological molecules formed on clay surfaces or within microscopic mineral compartments near the seafloor. There are also scientists who suspect pieces of the puzzle may have arrived from space itself. Organic molecules exist throughout the cosmos. Meteorites have been found carrying amino acids and carbon compounds. A controversial idea known as panspermia suggests that some ingredients for life, or perhaps even primitive microbes themselves, could potentially survive transport through space under certain conditions. Most researchers do not believe complex life arrived fully formed from elsewhere, but the possibility that some molecular ingredients came from beyond Earth remains difficult to completely dismiss. In a strange way, the deeper science investigates the origins of life, the more the story expands outward into the universe itself. But regardless of where the ingredients came from, Earth eventually crossed a threshold that changed the planet forever. Somewhere in those ancient oceans, molecules began replicating themselves. That ability may sound simple now, but replication changes everything. Once information can copy itself imperfectly, evolution begins. Small differences emerge. Some versions survive longer than others. Gradually, complexity accumulates. And from that point onward, Earth was no longer just a planet shaped by geology and chemistry. It became a biological world. Yet, at first, life remained almost unimaginably small. For billions of years, there were no animals, forests, or complex organisms anywhere on Earth. The planet belonged entirely to microscopic life forms, drifting through oceans beneath dark skies. If you could somehow travel back to that era, the world might still appear empty from a distance. But beneath the surface, life would already be spreading slowly across the planet. Ancient microbes formed strange layered structures called stromatolites in shallow waters, trapping sediment and building stone-like towers over immense stretches of time. Some fossil stromatolites survive today, making them among the oldest visible signs of life ever discovered. Looking at them feels oddly surreal because these structures were already ancient long before dinosaurs existed. Some are more than 3 billion years old. The mind struggles to process timescales like that. And perhaps the strangest part is how simple life remained for so incredibly long. Humans tend to imagine evolution as a steady march toward complexity. But for most of Earth's history, microscopic organisms dominated almost completely. Complex multicellular life appeared surprisingly late. For billions of years, bacteria-like organisms ruled the oceans, while continents remained mostly barren and lifeless. The Earth was alive, but only barely visible. And yet, those tiny organisms were quietly transforming the planet in ways that would eventually reshape the atmosphere, oceans, and future of life itself. Some ancient microbes evolved the ability to perform photosynthesis, using sunlight to produce energy. Modern plants do this now, but early photosynthetic microbes changed Earth on a planetary scale. Before their appearance, oxygen was almost absent from the atmosphere. But over immense spans of time, these microscopic organisms released oxygen as a byproduct into the oceans, and eventually, the air itself. At first, the oxygen reacted with dissolved iron in seawater, creating enormous deposits of iron-rich rock that still exist today. Entire geological formations across Earth may be ancient evidence of microscopic life slowly poisoning its own environment. Because, for many early organisms, oxygen was not beneficial, it was toxic. One of the most important turning points in Earth's history may actually have been a global environmental catastrophe caused by life itself. Scientists call this period the Great Oxygenation Event. As oxygen levels rose, countless ancient microbes adapted, retreated into isolated environments, or disappeared entirely. But oxygen also unlocked new possibilities. Eventually, it allowed more complex forms of life to emerge, because oxygen-based metabolism produces far more energy than earlier biological systems. In other words, every breath taken by animals today may trace back to ancient microbes transforming the atmosphere billions of years ago. That realization changes the feeling of the modern sky. The air itself becomes part of Earth's biological history. But during those early ages, the world still would have seemed profoundly alien to human eyes. The oceans may have carried unusual colors due to dissolved minerals and microbial activity. Purple, green, or rust-colored waters are all considered possible in certain ancient environments. Some researchers suspect thick microbial mats coated shallow coastlines beneath hazy skies, while volcanic activity remained common across the planet. There were no fish swimming through coral reefs, no trees casting shadows over rivers, no insects filling the air with sound. Earth remained eerily quiet despite being alive. And in many ways, that silence makes the emergence of life feel even stranger. Because the first organisms appeared not in comfort, but in extremes. Darkness, pressure, heat, toxic chemistry, constant instability. Modern humans often think of life as fragile, yet the earliest life on Earth may have been astonishingly resilient from the very beginning. Some modern microorganisms survive inside volcanic rock, beneath Antarctic ice, deep underground, and near boiling water. Certain microbes can endure radiation levels that would kill most organisms instantly. Looking at these extremophiles today raises unsettling possibilities. Perhaps life does not require gentle conditions at all. Perhaps it naturally emerges wherever chemistry and energy remain stable long enough. If that idea is true, then the universe could potentially contain far more life than humans once imagined. But Earth still holds the only confirmed example, and that makes the ancient oceans feel even more mysterious. Somewhere in those dark waters, matter organized itself into something capable of survival, replication, and evolution. Somewhere beneath storms no human ever witnessed, the first ancestors of every plant, animal, and person alive today were already drifting through the sea. No civilization recorded it, no consciousness observed it. The transformation happened entirely in darkness. And perhaps that is what makes the origin of life feel almost haunting when viewed across deep time. The most important turning point in Earth's history may have begun in silence, at the bottom of an ancient ocean, inside a world that still had no idea what it was becoming. There may have been a time when Earth looked less like a blue planet and more like a frozen moon drifting silently through space, long before forests covered the continents or animals crossed the oceans. The entire world may have fallen into an ice age so extreme that glaciers reached the equator and the seas themselves nearly vanished beneath a shell of frozen white. Scientists still debate exactly how complete this freeze became, but the possibility alone changes the way ancient Earth feels. Because if the snowball Earth hypothesis is even mostly correct, then life on this planet survived one of the most hostile climate disasters in planetary history. Imagine standing above Earth during that era, looking down from space. The oceans no longer shimmer dark blue beneath clouds. Instead, sunlight reflects almost everywhere off endless ice. The continents disappear beneath frozen deserts. Storm systems move across a pale world locked in silence. The planet does not look dead exactly, but it no longer looks alive either. And the strangest part is that this catastrophe may have been triggered not by violence from space or giant volcanic eruptions, but by climate itself spiraling out of balance. The Earth has always depended on delicate feedback systems. Even now, small changes in temperature can influence clouds, oceans, ice coverage, and atmospheric chemistry in ways that ripple outward across the entire planet. Billions of years ago, those systems may have tipped into something catastrophic. One leading idea suggests that as ice expanded across the surface, more sunlight reflected back into space instead of warming the Earth. That cooling created more ice, which reflected even more sunlight, causing temperatures to fall further. A chain reaction began. Once enough of the planet froze, reversing the process may have become almost impossible. Scientists call this the ice albedo feedback effect, but the science behind it feels far more cinematic than technical. The planet essentially trapped itself inside its own reflection. Some evidence suggests these freezing events happened roughly between 700 and 600 million years ago, during the Cryogenian period. Geological clues appear in rocks scattered across multiple continents, including signs of glaciers existing near what would have been tropical latitudes at the time. That detail is what shocked researchers most. Glaciers near the equator should have been extremely unlikely under normal conditions. Yet the rocks seem to suggest exactly that. If those interpretations are correct, Earth may have experienced temperatures colder than almost anything in its previous history. Oceans froze across enormous distances. Ice sheets thickened for millions of years. The world entered a state almost unimaginable from the perspective of modern civilization. But scientists still disagree on just how complete the freeze became. Some researchers argue the oceans may have frozen entirely over, with ice kilometers thick. Others believe patches of open water survived near the equator or around volcanic regions. A different interpretation, called slushball Earth, proposes the planet was not completely frozen, but still endured brutally cold conditions with partially open seas in certain regions. The debate continues because Earth's ancient history rarely leaves behind perfectly clear answers. The farther back scientists look, the more the planet seems to guard its secrets beneath fragmented evidence and geological scars. Yet, regardless of whether the freeze was total or partial, the implications remain extraordinary. Life survived. Somehow, beneath crushing cold and fading sunlight, microscopic organisms endured conditions that should have pushed the biosphere close to collapse. And perhaps the oceans beneath the ice became stranger than any modern environment on Earth. If thick ice sealed much of the surface, sunlight would barely penetrate into the waters below. Photosynthesis would decline dramatically. Entire ecosystems may have vanished. Yet, hydrothermal vents deep beneath the oceans continued releasing heat and minerals from Earth's interior exactly as they always had. Some scientists suspect these regions became critical refuges for life during the frozen ages. In the darkness beneath global ice, ancient microorganisms may have clustered around warm volcanic vents, surviving in isolated pockets while the rest of the world remained trapped in deep freeze. There is something haunting about that image. Tiny forms of life holding on beneath kilometers of ice, while the surface above became almost unrecognizable. And strangely, the frozen Earth may have looked beautiful, in a terrifying way. Modern polar regions already create an atmosphere of silence, unlike almost anywhere else on the planet. Snow absorbs sound. Ice stretches endlessly beneath pale skies. Now imagine that feeling expanded across nearly the entire globe. Winds moved across frozen oceans. Volcanoes erupted through glaciers. The sun reflected harshly across white continents where almost nothing stirred. Earth would have resembled a cosmic wilderness more than the living world humans know today. Some researchers even compare it to icy moons orbiting distant planets. In certain moments, ancient Earth may have looked more alien than Mars appears now. But eventually, after millions of years trapped in cold, the planet began changing again. The mechanism that may have ended Snowball Earth is one of the most fascinating parts of the story. Even during global freezes, volcanoes continued erupting. They released carbon dioxide into the atmosphere over immense stretches of time. Normally, rainfall and oceans help remove carbon dioxide from the air through geological cycles. But if much of Earth's surface was frozen, those processes slowed dramatically. Gradually, greenhouse gases built up in the atmosphere with nowhere to go. Over millions of years, the warming effect intensified until eventually the frozen balance collapsed. The thaw may have happened rapidly on geological timescales, and if that interpretation is correct, the transition would have been catastrophic in its own way. Imagine glaciers melting across continents simultaneously, ice-covered oceans breaking apart, sea levels shifting violently, enormous floods surging across barren terrain. Some scientists think the aftermath may have produced an intensely humid greenhouse world with extreme weather and rapidly changing oceans. Earth did not return gently from its frozen state. It may have swung suddenly from one climate extreme into another. Yet, hidden inside this chaos was another transformation even more important. Many researchers believe the environmental pressures surrounding these frozen periods may have influenced the later rise of complex multicellular life. After Snowball Earth ended, the fossil record eventually begins revealing increasingly sophisticated organisms unlike the microscopic worlds that dominated earlier ages. The exact connection remains uncertain, but some scientists suspect the harsh conditions forced evolutionary innovation in ways that reshaped life permanently. Environmental stress may have altered ocean chemistry, nutrient cycles, and ecological relationships across the entire planet. In a strange way, one of Earth's greatest climate catastrophes may also have helped prepare the conditions for more advanced life forms later on. That possibility changes the emotional tone of the frozen world. The ice no longer feels like a dead end. It feels like part of a larger transformation the planet was still moving through. And yet, the deeper researchers study Snowball Earth, the stranger the story becomes. Some evidence suggests glaciers reached tropical oceans where sunlight remained relatively intense. Other clues imply certain regions may have retained thin bands of open water despite the cold. There are even questions about how photosynthetic organisms survived prolonged darkness if ice coverage became too extensive. different models produce different outcomes. No single explanation perfectly answers every problem. And perhaps that uncertainty is exactly what makes the ancient Earth feel so compelling. The planet was not following a simple path toward modern life. It repeatedly approached conditions that seem almost incompatible with survival at all. Looking backward now, it becomes difficult not to wonder how many times Earth nearly failed. A slightly different atmosphere, a slightly weaker volcanic recovery, a slightly harsher freeze, and the future of life may have changed completely. Humanity often imagines Earth as stable because human civilization developed during an unusually calm climatic period. But deep time tells another story entirely. The ancient planet was unpredictable, extreme, and often hostile even to the life already living there. Continents drifted, oceans changed chemistry, the atmosphere transformed repeatedly, entire climates collapsed. And through all of it, life adapted with astonishing persistence. That resilience may be one of the defining characteristics of Earth itself. Even under a frozen sky, something survived. Even beneath endless ice, evolution continued quietly in darkness. Perhaps that is why Snowball Earth still captures scientific imagination so powerfully. It forces a realization that feels almost uncomfortable. The modern world humans take for granted is not permanent. Earth has worn radically different faces before. Tropical oceans once froze. Deserts once lay beneath ancient seas. Regions now covered in forests may someday disappear beneath ice again. Geological time transforms everything eventually. And somewhere inside the frozen silence of that ancient world, beneath glaciers stretching toward the equator, life waited patiently for the planet to thaw. Long before dinosaurs thundered across the Earth, before the first bird ever crossed the sky, the planet entered an age of forests so strange and oversized that modern Earth barely offers anything comparable. The world was warmer then, wetter in many regions, and thick with plant life unlike the forests humans know today. If you walked through those ancient landscapes during the Carboniferous period, roughly 300 million years ago, you would not feel like you had traveled into the distant past. You would feel like you had stepped onto another planet entirely. The air itself would seem different almost immediately, heavier somehow, richer, easier to breathe, but also strangely intense. Scientists believe oxygen levels during parts of the Carboniferous may have climbed far higher than modern levels, perhaps reaching over 30% of the atmosphere, compared to about 21% today. That single difference may have reshaped nearly everything living on land. Fires burned differently. Creatures grew differently. Even movement through the forests may have felt unusual beneath that oxygen-rich sky. And those forests were immense. Not necessarily in the sense of towering redwoods or modern jungle canopies, but in density, scale, and alien structure. Giant swamp forests stretched across enormous regions near the equator, covering parts of what are now North America, Europe, and Asia. Much of the land existed as humid lowlands, flooded by rivers, shallow seas, and endless wetlands. Thick vegetation spread outward in every direction through warm mist and dim light. But the trees themselves were not true trees in the modern sense. Many belonged to ancient plant groups, now extinct, or reduced to tiny descendants, almost unrecognizable compared to their former size. Massive lycopsids rose like scaled pillars from the swamp floor, some reaching over 100 feet tall. Giant horsetails grew in dense clusters beside dark waterways. Fern-like forests spread beneath heavy clouds where little sunlight reached the ground. Yet despite their size, many of these plants lacked the dense wood modern trees use for support. Some were more closely related to mosses and club mosses than to oaks or pines. The ancient world experimented with forms of life that no longer dominate Earth today. And perhaps the strangest part is how quiet those forests might have sounded. There were no birds singing overhead, because birds did not yet exist. No mammals moved through the undergrowth. No flowering plants filled the air with scents or colors. Instead, the sounds came from wind moving through giant fronds, distant thunder, rushing water, and the movements of creatures that now seem almost impossible. Because the oxygen-rich atmosphere may have allowed arthropods to grow to enormous sizes. Dragonflies with wingspans wider than hawks drifted through humid air above the swamps. Giant millipede-like creatures crawled across the forest floor, some reaching lengths over 6 feet. Ancient forest scorpions moved through shallow waters, while spiders and insects occupied ecological roles long before reptiles fully dominated the land. Scientists still debate exactly how much oxygen contributed to these gigantic sizes, but evidence strongly suggests atmospheric conditions played an important role. Insects breathe differently than mammals do. Their respiratory systems depend partly on diffusion through tiny openings in their bodies, which limits how large they can grow under modern oxygen levels. But during the Carboniferous, those limits may have changed dramatically. The atmosphere itself helped create giants. Walking through those forests at night would have been deeply unsettling. Thick fog rising from warm wetlands, massive insects gliding silently between shadows, endless dark vegetation disappearing into swamp water beneath a sky untouched by artificial light. The moon and stars reflected across black pools, while unfamiliar creatures moved beneath the surface. Yet, despite the strange appearance, these forests were performing one of the most important transformations in Earth's history. They were changing the atmosphere and storing carbon on a scale difficult to fully comprehend. Plants absorb carbon dioxide during photosynthesis, locking carbon inside their tissues. When many of those ancient plants died, they fell into oxygen-poor swamp waters where decomposition slowed dramatically. Instead of fully breaking down, enormous amounts of plant material accumulated, layer upon layer, over millions of years. Pressure and time gradually transformed that buried organic matter into coal. Much of the coal humans later burned during the Industrial Revolution began as these prehistoric forests. In a strange sense, modern civilization partially runs on sunlight captured by plants hundreds of millions of years before humans existed. Every coal fire, every steam engine, every early factory was powered by ancient swamp ecosystems buried deep beneath the earth. That connection between the prehistoric world and modern industry feels almost eerie once you realize it. Entire human civilizations unknowingly depended on forests older than dinosaurs. But the Carboniferous forests were not stable paradises. Climate shifts, tectonic changes, and evolving ecosystems constantly reshaped the environment. Oxygen-rich atmospheres also made wildfires more intense. Some scientists suspect fires spread more easily during certain periods because vegetation burned so efficiently in high oxygen conditions. Evidence of ancient fires survives in fossil charcoal buried inside rock layers across the world. Even then, the planet balanced creation and destruction simultaneously. Life expanded into astonishing new forms, while environmental instability remained constant beneath the surface. And meanwhile, evolution kept moving. Earlier life on land had remained relatively simple near coastlines and wetlands. But by this period, ecosystems became increasingly complex. Plants spread deeper inland. Arthropods diversified. Early amphibians moved through swamps, hunting smaller creatures in shallow waters. Some researchers believe dense vegetation helped alter weather patterns and atmospheric chemistry on continental scales. Forests were no longer just passive life forms covering the Earth. They had become planetary forces influencing climate itself. And slowly, almost invisibly at first, another transformation was beginning beneath the shadows of those giant plants. The first reptiles emerged. This may sound small compared to giant insects or endless forests, but evolutionarily, it changed the future of Earth forever. Earlier, amphibian-like animals still depended heavily on water for reproduction. Their eggs required moist environments to survive. Reptiles evolved differently. Their eggs could survive on land, freeing them from permanent dependence on swamps and shallow water. That adaptation allowed vertebrate life to spread into drier environments across the continents. In many ways, the age of reptiles began quietly inside the margins of these ancient forests, long before dinosaurs appeared. The Carboniferous world was setting the stage for entirely new ecosystems still to come. Yet, despite all its biological innovation, the Earth during this era still looked profoundly unfamiliar compared to modern landscapes. Continents occupied different positions. Much of Earth's landmass was gradually assembling into the supercontinent Pangaea. Vast tropical wetlands stretched across equatorial regions, while other areas experienced harsher climates. Sea levels repeatedly rose and fell. Glaciers expanded in parts of the southern hemisphere, even while humid forests dominated elsewhere. Earth was becoming more geographically connected, and those continental collisions would eventually reshape global climates dramatically. But inside the forests themselves, life continued evolving through endless experimentation. Some ancient plants reached extraordinary heights, only to vanish completely from the future world. Entire evolutionary strategies disappeared forever. Looking backward now, the prehistoric forests feel almost dreamlike because they reveal how temporary dominance really is in Earth's history. Today, flowering plants dominate most terrestrial ecosystems. Mammals and birds fill the skies and forests. But for millions upon millions of years, the world belonged to entirely different forms of life. Giant club mosses once towered over the land where oak trees stand now. Dragonflies, the size of seabirds, drifted through oxygen-heavy air where airplanes fly today. The Earth keeps reinventing itself across deep time, and perhaps that is what makes these forests so fascinating. They were not primitive versions of the modern world. They were fully realized ecosystems, operating according to rules very different from those humans now consider normal. The deeper scientists study the Carboniferous, the clearer it becomes that Earth's past was not simply building toward humanity in a straight line. Evolution explored countless possibilities. Some succeeded briefly and vanished. Others quietly reshaped the future. The forests before dinosaurs existed, inside one of those strange turning points where the planet briefly became something almost impossible to imagine from a modern perspective. Dense jungles without flowers, giant insects ruling the air, endless wetlands beneath thick, oxygen-rich skies. A world both beautiful and unsettling in equal measure. And hidden beneath all that life, layer after layer, the remains of those forests slowly sank into darkness, waiting hundreds of millions of years for a future species to uncover them and burn the ancient sunlight trapped inside. Long before human beings feared what might exist beneath the surface of the ocean, the seas of Earth already belonged to creatures so strange and enormous that even modern marine life can feel tame by comparison. The ancient oceans were not calm blue worlds filled with familiar fish and coral reefs. They were vast biological frontiers where evolution experimented constantly, producing predators, armored giants, and forms of life that seem almost unreal today. And unlike the forests or deserts of prehistoric Earth, most of this world remained hidden even while it existed. Darkness covered the deeper waters. Entire ecosystems lived and died unseen beneath waves that crossed an empty planet long before humans ever imagined sailing across them. If you could somehow descend into those ancient seas hundreds of millions of years ago, the first thing you would notice would probably not be the creatures themselves. It would be the feeling that the ocean operated according to entirely different rules back then. The water chemistry was different. Oxygen levels changed over time. Continents occupied unfamiliar positions. Sea levels rose and fell across enormous stretches of Earth. Shallow inland seas covered regions that are now dry land. Entire marine ecosystems expanded across warm tropical waters where deserts and mountains exist today. The oceans were larger in some eras, stranger in others, and often far more dangerous than modern seas. Yet, for most of Earth's history, life remained primarily marine. Long before forests covered continents or animals conquered the land, the oceans had already become crowded battlefields of evolution. And some of the earliest rulers of those waters barely resembled anything alive today. During the Paleozoic era, particularly in the ancient seas of the Ordovician, Silurian, and Devonian periods, marine ecosystems exploded with diversity. Strange armored fish drifted through shallow waters, while giant arthropods hunted beneath the surface. Some creatures carried hard external shells. Others evolved primitive jaws capable of crushing prey. evolutionary arms races began reshaping life itself. Predators became faster, armor became thicker, senses became more refined. The oceans were no longer simple worlds filled only with microscopic organisms and soft-bodied life. They had become ecosystems driven increasingly by survival, competition, and fear. One of the strangest creatures of those early seas was the Eurypterid, sometimes called the sea scorpion. Despite the nickname, many were not true scorpions, though they belonged to related groups of arthropods. Some species remained relatively small, but others reached astonishing sizes. The largest known Eurypterids may have grown over 8 feet long, with powerful front limbs and bodies built for ambush hunting in shallow marine environments. Imagine standing in waist-deep prehistoric water while one of these creatures moved silently beneath the surface. Their bodies reflected dim sunlight through murky seas, while primitive fish scattered around them. The world before vertebrate dominance belonged partly to these ancient hunters, yet even they would eventually lose control of the oceans to something even more transformative: fish with jaws. Before jaws evolved, early vertebrates fed in limited ways, often filtering particles or sucking food into their mouths. But once jaws appeared, entirely new ecological possibilities opened. Suddenly, animals could seize prey, tear flesh, crush shells, and dominate food chains more aggressively than before. Among the most famous predators of this age was Dunkleosteus, a giant armored fish from the Devonian period, roughly 360 million years ago. Some estimates suggest it reached lengths around 30 feet, though scientists still debate exact sizes because complete skeletons remain rare. Unlike sharks, Dunkleosteus did not rely on rows of replaceable teeth. Instead, it possessed sharpened, bony plates capable of delivering terrifying bite forces. Some researchers believe its jaws closed with explosive speed, making it one of the most formidable predators of its time. In a strange way, it looked less like a modern fish and more like a living armored machine built from prehistoric nightmares. Yet, the deeper scientists study these ancient predators, the more complex the oceans become. Not every giant ruled through speed or violence alone. Some marine organisms evolved elaborate defensive structures. Others relied on camouflage, filter feeding, or slow movements near the sea floor. Ancient reefs spread across warm, shallow seas. But these reefs often looked different from modern coral systems. Entire groups of reef-building organisms rose and vanished across geological time. Ocean ecosystems repeatedly reinvented themselves after extinctions, and climate shifts altered the balance of life. And those extinctions happened often. The seas before humans were not stable kingdoms ruled permanently by single species. They were constantly changing worlds shaped by catastrophe. Oxygen levels in the oceans fluctuated dramatically through deep time. Sometimes large regions of seawater lost oxygen entirely, creating deadly zones where many organisms could not survive. Volcanic activity altered ocean chemistry. Climate changes shifted sea levels. continents collided and separated, redirecting currents and transforming habitats across the globe. Entire marine food webs collapsed more than once. Some of the greatest extinction events in Earth's history struck the oceans first and hardest. Yet, after every collapse, life adapted again. New predators emerged. New ecosystems spread across recovering seas. And eventually, during the age of reptiles, the oceans produced creatures so enormous and bizarre that they still dominate popular imagination today. It is important to remember that most marine reptiles were not dinosaurs, even though they lived during similar eras. The oceans developed their own separate giants. Ichthyosaurs evolved sleek bodies resembling dolphins or sharks, despite having entirely different ancestry. Some grew enormous, with giant eyes adapted for hunting in deep, dark waters. Plesiosaurs moved through ancient seas with long necks and powerful flippers. Mosasaurs, distant relatives of monitor lizards, became apex predators later in the Cretaceous oceans. And unlike many earlier marine hunters, some of these reptiles gave birth to live young instead of laying eggs on land, allowing them to spend nearly their entire lives at sea. The oceans had become worlds capable of supporting giant, air-breathing predators adapted almost completely to marine existence. Yet, perhaps the most unsettling thing about these ancient oceans is how unfamiliar they might have felt, even beyond the creatures themselves. The water often carried different chemistry and temperatures than modern seas. During certain warm periods, tropical conditions extended much farther toward the poles. Sea levels rose high enough to flood continental interiors, creating shallow inland seas stretching across huge regions of Earth. North America itself was once partially divided by a vast prehistoric seaway filled with marine predators. Imagine standing where dry plains exist today, while waves roll overhead, filled with giant reptiles hunting beneath the surface. The continents humans now have repeatedly disappeared beneath ancient oceans, and even in the open seas, survival was never guaranteed. Some prehistoric sharks grew to massive sizes. Others evolved crushing jaws capable of feeding on armored prey. Ancient cephalopods moved through the waters with spiral shells or squid-like bodies. Giant ammonites drifted across the oceans for millions of years before vanishing completely during the same extinction event that ended the age of dinosaurs. Looking at their fossils now feels almost melancholy, because these creatures once dominated the seas across unimaginable spans of time, only to disappear forever. That pattern repeats constantly throughout marine history. Dominance in Earth's oceans is temporary. Entire dynasties of life rise and vanish beneath the waves. And perhaps nowhere does Earth's indifference feel clearer than in the oceans. The sea does not preserve civilizations or monuments. It swallows them. Even today, humans have explored only a fraction of the deep ocean floor. The ancient seas were even more mysterious because nothing observed them consciously for most of their history. Creatures hunted, migrated, reproduced, and vanished entirely beneath waters no human eyes would ever witness. The deeper parts of the ocean remained hidden kingdoms of pressure and darkness, where evolution unfolded almost invisibly. Some scientists suspect giant marine animals occasionally evolved larger sizes, partly because water supports body weight differently than land. Massive creatures can move through oceans more efficiently than they could across solid ground. Others point toward abundant food sources, oxygen conditions, or evolutionary competition driving gigantism in certain eras. No single explanation perfectly accounts for every marine giant Earth produced, but the pattern itself is unmistakable. Again and again, the oceans created monsters. And perhaps the strangest realization comes from understanding that the oceans themselves are ancient beyond human intuition. Much of the water moving through modern seas has cycled through Earth's systems for billions of years. The tides that shape coastlines today once moved through prehistoric oceans filled with creatures no human would recognize. Storms crossed seas ruled by armored fish long before mammals evolved. The Atlantic Ocean itself did not even exist during many of these ancient ages. Entire ocean basins opened and closed across deep time, while marine life adapted continuously to changing worlds. Looking backward now, the prehistoric oceans begin to feel less like a single environment and more like countless different alien worlds layered across Earth's history. Some were warm and shallow, others dark and oxygen-poor. Some filled with giant reptiles, others dominated by armored fish or bizarre arthropods. The sea kept reinventing itself, just as life did. And hidden beneath every wave was the same silent reality that has followed Earth since the beginning. Survival never lasted forever. Even the greatest monsters of the oceans eventually disappeared into extinction, leaving behind only fragments buried in stone beneath continents that once lay underwater. When most people imagine the age of dinosaurs, they picture a world built almost entirely from movies. Endless jungles steaming beneath volcanoes, giant reptiles roaring constantly, while massive predators chase terrified prey across open plains. But the real Earth of the dinosaurs was far stranger, quieter in some ways, and scientifically far more fascinating than the version popular culture created. Because dinosaurs did not live inside one single lost world. They ruled the planet for an almost incomprehensible span of time, stretching across more than 160 million years. That is such a vast period. The Tyrannosaurus rex lived closer in time to modern humans than it did to some of the earliest dinosaurs. Entire ecosystems rose and vanished during the dinosaur era alone. Continents split apart. Oceans opened. Climates transformed repeatedly. The age of dinosaurs was not a frozen prehistoric snapshot. It was a constantly changing planet, evolving for millions upon millions of years, while dinosaurs adapted alongside it. And perhaps the first surprise is that the world itself often looked less familiar than the dinosaurs living in it. If you stepped into certain periods of the Mesozoic era, you might notice something unsettling almost immediately. The plants are wrong. There is no grass beneath your feet. Grasslands, one of the defining features of many modern landscapes, barely existed for most of dinosaur history. Instead, forests of conifers, cycads, ferns, and ancient relatives of pine-like plants covered huge regions of the earth. Flowering plants did not dominate the world yet. In fact, flowers themselves appeared surprisingly late. For much of the dinosaur age, Earth was green. But it was a very different green from the modern world. Forests often looked darker, denser, and more primitive. Some regions resembled subtropical wetlands, while others stretched into dry deserts across the supercontinent Pangaea. And above it all, the climate itself behaved differently. During many parts of the dinosaur era, Earth was significantly warmer than today. There were periods when little or no permanent ice existed at the poles. Tropical conditions reached far into higher latitudes. Sea levels often stood much higher than modern oceans, flooding continental interiors and creating enormous shallow seas. Some scientists believe carbon dioxide levels remained elevated for long stretches of time, due partly to volcanic activity and tectonic changes reshaping the planet. But even the climate story is more complicated than it first appears. Not every part of dinosaur history was uniformly hot. Certain periods may have experienced cooler intervals, seasonal variations, and even polar regions cold enough for snow during darker months. Recent evidence suggests some dinosaurs survived in environments once assumed too cold for them entirely. That realization alone changed how scientists viewed dinosaur biology. For decades, dinosaurs were often portrayed as sluggish, cold-blooded reptiles dependent on warm climates. But newer discoveries suggest many species may have been far more active, adaptable, and metabolically complex than earlier generations believed. And nowhere is that shift more visible than in the discovery of feathers. Perhaps no scientific revelation transformed public understanding of dinosaurs more dramatically than the growing evidence that many species possessed feathers or feather-like coverings. Today, the connection between birds and dinosaurs is widely accepted within paleontology. But that idea once seemed almost absurd to many people. Yet fossil after fossil began revealing preserved feathers on numerous dinosaur species, especially smaller theropods closely related to birds. Some had simple filament-like structures. Others possessed complex feather arrangements remarkably similar to modern birds. Suddenly, the image of dinosaurs changed forever. The giant scaly monsters of old movies no longer fully matched reality. Some predators may have displayed colorful plumage. Others could have used feathers for insulation, communication, mating displays, or protecting eggs. And perhaps the strangest implication of all is that birds themselves are not merely descendants of dinosaurs in a loose sense. Scientifically speaking, birds are dinosaurs. The dinosaur lineage never vanished completely. It still fills modern skies every day. But the deeper researchers study dinosaur behavior, the more unfamiliar these animals become. Fossilized nests suggest certain species cared for their young. Bone structures indicate some dinosaurs grew surprisingly fast. Evidence from trackways hints that certain herbivores traveled in groups across ancient floodplains. Some predators may have hunted cooperatively under specific conditions, though debates continue over how complex dinosaur social behavior truly became. The old image of dinosaurs as oversized lizards acting entirely on instinct grows weaker with every decade of research. Many species likely possessed behaviors more dynamic and varied than earlier scientists imagined. Yet, despite all this new understanding, the real dinosaur world still carried an atmosphere almost impossible for modern humans to fully process. The sounds alone would have felt alien. No human being has ever heard a living dinosaur roar. Popular culture invented many of those sounds completely. In reality, some scientists suspect certain dinosaurs may have produced deep resonating calls more similar to birds, crocodilians, or low-frequency vibrations than dramatic cinematic roars. Giant herbivores moving through forests may have communicated across long distances using sounds humans would feel before hearing. Smaller feathered predators may have hissed, chirped, clicked, or produced calls unlike anything alive now. The Mesozoic world may have sounded deeply unfamiliar even before the animals themselves appeared, and the sky above them was different too. During the Triassic period, much of Earth's land remained joined together inside the supercontinent Pangaea. Vast interior deserts stretched across enormous distances where seasonal heat could become extreme. Later, during the Jurassic and Cretaceous periods, continents slowly drifted apart, opening new coastlines and changing weather patterns across the globe. Oceans reshaped ecosystems. Isolation drove evolution in different directions on separate land masses. Dinosaurs adapted continuously to shifting environments over immense timescales. Some species grew colossal sizes, partly because certain ecosystems provided abundant vegetation and ecological opportunities, unlike anything modern Earth supports. Giant sauropods, weighing dozens of tons, crossed prehistoric landscapes where entire forests existed to sustain them. Yet, even these giants likely spent much of their lives engaged in ordinary biological struggles: feeding, migrating, avoiding drought, protecting offspring, surviving injuries. And despite their dominance, dinosaurs were not alone. Mammals already existed during much of the dinosaur era, though they remained relatively small for millions of years. Early mammals moved through shadows beneath giant reptiles, surviving as nocturnal creatures, burrowers, climbers, and insect hunters. Insects diversified, birds evolved. Flying reptiles called pterosaurs ruled the skies long before true birds became widespread. Marine reptiles dominated ancient oceans. The world of dinosaurs was not a single species kingdom. It was a planet-wide network of evolving ecosystems filled with competition and adaptation. Yet perhaps the most surprising truth is how normal dinosaurs may have seemed within their own world. To modern humans, a giant sauropod appears almost mythical because no comparable land animals exist now. But during the Jurassic, such creatures were simply part of the environment. Young dinosaurs hatched, fed, migrated, reproduced, and died beneath ordinary weather patterns repeated season after season for millions of years. Evolution had stabilized around forms that now feel impossible only because Earth no longer supports them. And over all those millions of years, extinction remained constant even within the dinosaur age itself. Species disappeared continuously. New predators replaced old ones. Entire ecosystems shifted with climate and geography. The age of dinosaurs was not one endless, uninterrupted reign. It was a long sequence of changing worlds where survival remained temporary for every species, no matter how successful. Looking backward now, perhaps the most cinematic part of the dinosaur era is not the violence or the size of the creatures. It is the scale of time itself. Dinosaurs dominated Earth so long that mountain ranges rose and eroded away while they still existed. Oceans opened between continents. Atmospheric chemistry shifted. Entire evolutionary experiments appeared and vanished beneath their feet. Human civilization feels ancient to us at a few thousand years old. Dinosaurs ruled across spans of time almost impossible for the human mind to emotionally process. And yet, despite all that dominance, they still disappeared. Not because they were weak or poorly adapted, but because Earth itself remained unstable beneath every age that ever existed. The real world of dinosaurs was not a fantasy kingdom frozen in permanent sunlight. It was a living planet, constantly changing around them. Feathered hunters crossed fern-covered floodplains beneath skies filled with giant flying reptiles. Polar forests supported species adapted to months of darkness. Massive herbivores wandered through landscapes with no grass at all. And somewhere far above that ancient Earth, long before humans existed to study any of it, the future extinction of the dinosaurs was already moving silently through space. For most of Earth's history, extinction was not rare. It was normal. Entire species disappeared constantly, while new ones evolved in their place. But scattered across deep time are moments so catastrophic that they reshaped almost the entire planet at once. Oceans collapsed. Forests vanished. Food chains broke apart. The sky itself changed. These were not ordinary extinctions where a few unlucky creatures failed to adapt. These were planetary disasters powerful enough to erase dominant life forms that had ruled Earth for millions of years. And perhaps the most unsettling part is how suddenly some of these worlds disappeared. One day, ancient ecosystems stretched across continents and oceans as they always had. Then something shifted beneath the surface of the planet, or above it in space, and the balance holding life together began to fail. Looking backward now, Earth's history starts to feel strangely fragile. Entire ages ended because of forces no creature could control or even understand. One of the worst catastrophes in Earth's history happened long before the dinosaurs disappeared. Around 252 million years ago, near the end of the Permian period, the planet entered a crisis so severe that scientists often call it the Great Dying. Even today, researchers still debate exactly how extreme conditions became during this extinction event. But estimates suggest roughly 90% of marine species and a massive percentage of land species vanished. Entire ecosystems collapsed almost completely. The Earth did not simply lose a few dominant animals. It nearly lost complexity itself. And unlike the sudden asteroid impact often associated with dinosaur extinction, The Permian catastrophe may have unfolded over longer stretches of time through a chain reaction of environmental disasters feeding into one another. One leading explanation points toward enormous volcanic eruptions in what is now Siberia. These eruptions were not ordinary volcanoes, comparable to modern eruptions lasting days or weeks. The Siberian traps may have erupted on unimaginable scales for hundreds of thousands of years, covering vast regions with lava, while releasing enormous amounts of carbon dioxide, methane, and toxic gases into the atmosphere. The climate began changing rapidly. Temperatures rose, oceans warmed, oxygen levels in seawater dropped dangerously low. Some scientists believe entire regions of the oceans became nearly uninhabitable, creating vast dead zones where marine life suffocated. Acidification may have damaged shell-forming organisms, while warming climates disrupted food chains on land and sea simultaneously. And as ecosystems weakened, collapse spread outward through the biosphere. Forests died, predators lost prey, stable climates disappeared. Earth entered one of the darkest biological crises in its history. If you could stand on the planet during the late stages of the Permian extinction, the world might have felt eerily empty in certain regions. Forests reduced to dead landscapes, rivers carrying ash and sediment through devastated ecosystems, oceans growing stagnant beneath warming skies. And perhaps the most haunting detail is that life survived only in fragments. Certain organisms endured because they happened to possess traits suited for chaos: tolerance to heat, flexibility in diet, resistance to low oxygen environments. Survival became less about dominance and more about endurance. The rulers of one age vanished, while overlooked survivors inherited the future. Yet, even after the Great Dying ended, Earth did not fully stabilize for a long time. Recovery may have taken millions of years. Ecosystems remained simplified and strange. Some scientists believe fungal growth spread widely across dead forests during the aftermath. Others suggest unstable climates continued reshaping the planet repeatedly. Looking at this extinction now, it no longer feels like a single disaster. It feels like Earth's entire life support system temporarily malfunctioning. And somehow, life rebuilt itself anyway. New reptiles emerged. Oceans slowly recovered. Forests returned. Eventually, dinosaurs rose into dominance. But the lesson hidden inside the Permian extinction never disappeared. Even the most successful ecosystems in Earth's history could collapse under enough environmental pressure. And millions of years later, another catastrophe arrived from the sky. The asteroid impact that ended the age of dinosaurs remains one of the most famous extinction events ever studied, partly because its evidence still exists in such dramatic form. Around 66 million years ago, a massive asteroid, roughly 6 miles wide, struck near what is now the Yucatan Peninsula in Mexico. The impact released energy far beyond anything produced by human civilization. In seconds, landscapes vaporized. Shock waves raced outward faster than sound. Forests near the impact zone likely ignited almost instantly, while molten debris blasted high into the atmosphere before raining back across the planet. Some researchers think portions of Earth's surface briefly heated enough to trigger wildfires on continental scales. Tsunamis spread across ancient coastlines. Earthquakes shook regions thousands of miles away. But the most devastating effects may have unfolded afterward. Dust, soot, and vaporized material entered the atmosphere in enormous quantities, blocking sunlight around the globe. Photosynthesis declined dramatically. Temperatures dropped. Food chains began collapsing from the bottom upward. Herbivores starved. Predators followed. Marine ecosystems suffered alongside terrestrial ones as plankton populations crashed. The world entered a period of darkness and environmental instability unlike anything dinosaurs had previously endured. Yet even here, scientists continued debating details. Some researchers argue volcanic activity already stressed ecosystems before the asteroid impact occurred. Massive eruptions in India, known as the Deccan Traps, released enormous quantities of gases during roughly the same period. Perhaps ecosystems were already weakened before the asteroid struck. Others maintain the impact itself drove most of the extinction directly. There may never be perfect agreement, because Earth's history rarely leaves behind simple explanations. Catastrophes often overlap, interact, and amplify one another. But regardless of the precise sequence, the result changed the future of life permanently. Non-avian dinosaurs disappeared. Giant marine reptiles vanished. Countless species died across land and sea. And yet again, certain survivors endured, while dominant rulers of the planet vanished forever. Small mammals survived partly because flexibility became an advantage in collapsing ecosystems. Burrowing species, scavengers, and generalists endured conditions that destroyed larger, specialized predators. In deep time, survival often favors adaptability more than strength. Looking at these extinction events together creates an unsettling realization. Earth does not guarantee stability for any species, no matter how dominant it appears. Dinosaurs ruled for over 160 million years, an incomprehensibly long reign compared to human civilization. Yet they disappeared within a relatively brief geological moment because the planet itself changed faster than many ecosystems could adapt. And the asteroid impact was not Earth's only cosmic threat. Throughout history, the planet has endured repeated collisions with objects from space. Most were far smaller than the Chicxulub impactor. But evidence suggests impacts shaped Earth repeatedly across deep time. Some scientists even suspect certain ancient extinctions may involve combinations of volcanism, climate shifts, ocean chemistry changes, and impacts acting together. Earth's biosphere exists inside a system constantly influenced by both internal geology and external cosmic events. That balance remains more fragile than it appears from a human perspective. Yet perhaps the most fascinating part of these catastrophes is what happened afterward. Life always returned differently. The world after the Permian extinction was not the same world rebuilt exactly as before. New ecosystems emerged. New evolutionary opportunities appeared. The same happened after the asteroid impact. Mammals diversified into niches dinosaurs once occupied. Forests recovered under altered climates. Birds survived and spread across skies once ruled by giant reptiles. Earth's history repeatedly demonstrates not just destruction, but transformation through destruction. Extinction events function almost like planetary resets, reshaping the direction of evolution itself. And sometimes, the survivors seem almost accidental. Certain lineages persist because of geography, diet, size, or environmental luck, rather than superiority. Looking backward now, human existence begins to feel strangely dependent on ancient catastrophes. If the Permian extinction never happened, dinosaur ancestors may never have risen the same way. If the asteroid missed Earth 66 million years ago, mammals might have remained small, shadow-dwelling creatures far longer. Entire branches of future evolution depended partly on disasters no living organism could predict. The modern world was shaped not only by survival, but by extinction. And perhaps that is what makes Earth's history feel simultaneously beautiful and terrifying. Life is resilient, but not invincible. Civilizations often imagine stability as permanent because human lifespans are short compared to geological time. Yet deep time tells another story entirely. Oceans can become toxic. Atmospheres can shift. Continents can transform climates. Objects from space can erase dominant species in a geological instant. The Earth beneath every ecosystem remains dynamic, unstable, and capable of enormous change. Even now, traces of those ancient catastrophes remain visible. Buried crater scars, fossil layers marking sudden disappearances, ash deposits from ancient eruptions, strange gaps in the history of life where entire worlds ended. And somewhere inside those layers lies one of the deepest truths about Earth itself. Every age once believed it was permanent. Every dominant species ruled as if its world would last forever. But eventually, the planet changed again, and the survivors inherited a future the extinct could never have imagined. After the dinosaurs disappeared, the Earth did not suddenly become calm or familiar. The forests grew back. Rivers continued carving through continents. Oceans still moved beneath storm-dark skies. But the balance of life had changed permanently. For more than 160 million years, giant reptiles dominated most major ecosystems on land, sea, and air. Then, almost unbelievably fast in geological terms, they were gone. And into the silence they left behind stepped creatures that had spent millions of years surviving in the shadows. Small mammals, once hidden beneath the feet of dinosaurs, suddenly inherited a planet filled with empty ecological space. Forests without giant predators, plains without enormous herbivorous reptiles, oceans reshaped after marine extinctions. It was one of the greatest opportunities evolution had ever experienced. And over the next tens of millions of years, Earth produced a new generation of giants, unlike anything that came before. The age after dinosaurs was not an age of small, timid mammals slowly exploring a ruined world. It became another era of enormous creatures, strange predators, oversized birds, and ecosystems that would feel deeply unsettling to modern eyes. If you walked through parts of the Earth during the Paleogene and later periods, you might recognize the broad shape of mammals for the first time. In this story, fur-covered bodies, warm-blooded animals nursing their young, herd behavior beginning to resemble modern ecosystems. Yet, despite these familiar traits, many species still looked bizarre compared to animals alive today. Evolution was experimenting rapidly. Entire groups of mammals evolved into forms with no true modern equivalents. Some became massive herbivores, filling roles once occupied by dinosaurs. Others evolved into terrifying predators, adapted to a world still unstable and changing. And perhaps the strangest part is how quickly some of this happened. Once the ecological dominance of dinosaurs ended, mammals diversified with astonishing speed across geological time. One of the most haunting creatures of this age was Andrewsarchus, a predator known mostly from a giant skull discovered in Mongolia. Scientists still debate exactly what this animal looked like because the fossil record remains incomplete, but estimates suggest it may have been among the largest terrestrial mammalian carnivores ever to exist. Some reconstructions portray it as a wolf-like predator with crushing jaws, while others argue it may have resembled a strange, hoofed scavenger more closely related to ancient relatives of whales and pigs. That uncertainty itself captures something important about the post-dinosaur world. Many of its creatures still remain mysterious because no humans ever saw them, and the fossil evidence often survives only in fragments. Earth repeatedly created entire ecosystems now known mostly from scattered bones buried beneath rock and sediment. But giant predators were only part of the story. Enormous herbivores also spread across continents. Some ancient rhinoceros relatives became so massive they rivaled the size of certain dinosaurs. Paraceratherium, often considered the largest land mammal ever discovered, may have stood over 15 feet tall at the shoulder and stretched longer than many buses. Imagine an animal taller than a giraffe moving slowly through prehistoric forests with no elephants, no humans, and no large modern mammals anywhere nearby. The world after dinosaurs was still a world of giants. It simply replaced reptilian dominance with mammalian forms. And meanwhile, in the skies, another strange experiment unfolded. For a period after the extinction of dinosaurs, giant flightless birds became major predators in some regions. Often called terror birds, species like Phorusrhacos evolved powerful legs, hooked beaks, and intimidating heights capable of rivaling large mammals. In South America especially, these birds occupied apex predator roles for millions of years. Watching one cross an ancient plain may have felt deeply unnatural to human eyes. A giant bird running toward prey at terrifying speed beneath open prehistoric skies. In a strange way, the age after dinosaurs still carried echoes of the reptilian past, because birds themselves descended directly from dinosaurs. Evolution never truly erased the old world completely. Fragments of it survived and transformed into something new. But perhaps nowhere did gigantism become more famous than in the oceans. Millions of years after marine reptiles vanished, the seas produced another apex predator that still dominates imagination today: Megalodon. This enormous prehistoric shark may have reached lengths over 50 feet, though scientists continue debating exact estimates because sharks leave behind mostly teeth rather than complete skeletons. Still, even conservative reconstructions place Megalodon among the largest marine predators ever known. Its jaws could swallow prey whole. Massive serrated teeth larger than human hands hunted whales across ancient oceans. And, unlike the marine reptiles before it, Megalodon belonged to a lineage still surviving today. Modern sharks carry distant echoes of those ancient predators within their bodies. Yet, even the oceans after dinosaurs were changing rapidly. Whale ancestors evolved from land mammals that gradually adapted back into marine life. Early whales still possessed functional legs before evolution reshaped them into fully aquatic giants. That transformation remains one of the most astonishing evolutionary stories ever uncovered. Mammals, once hidden beneath dinosaur ecosystems, eventually returned to the oceans and became some of the largest animals Earth has ever produced. The blue whale, alive today, surpasses even the largest known dinosaurs in total mass. In a way, the post-dinosaur world eventually created giants beyond anything the ancient reptiles achieved. But life after dinosaurs was not simply growing larger. It was also becoming more specialized, more intelligent in some lineages, and more ecologically complex. Grasslands spread across parts of the Earth for the first time, changing herbivore evolution dramatically. Grazing animals emerged alongside faster predators adapted for open terrain. Climate shifts repeatedly altered forests, deserts, and coastlines. Continents continued drifting toward modern positions. Mountain ranges rose. Ocean currents changed global temperatures. The Earth was beginning to resemble the modern world more closely, but it still remained profoundly wild. And during the ice ages that arrived much later, another extraordinary collection of giant animals spread across the planet. Mammoths crossed frozen steppe landscapes beneath cold gray skies. Giant ground sloths wandered ancient forests in the Americas. Saber-toothed cats hunted massive prey with specialized jaws unlike any modern feline. Short-faced bears towered over modern grizzlies. Giant elk carried antlers stretching wider than cars. The world of megafauna was not fantasy. Humans actually lived alongside some of these creatures for a brief moment in deep time. That realization changes the emotional distance between the prehistoric world and modern humanity. The dinosaurs vanished long before humans existed, but mammoths, giant cats, and enormous Ice Age mammals survived close enough to overlap with early human history itself. And that overlap raises one of the most debated questions in paleontology and archaeology. What exactly caused many of these giant mammals to disappear? Climate change clearly played a role as Ice Age conditions shifted and habitats transformed. But some researchers also suspect expanding human populations contributed. through hunting pressure and ecosystem disruption. The debate remains complicated because extinction rarely follows one simple cause. Different regions lost megafauna under different conditions. Some species survived environmental changes for long periods before vanishing rapidly. Others disappeared shortly after human arrival in previously isolated ecosystems. There may never be a universal explanation covering every extinction event. But once again, the deeper story remains familiar. Earth created giants repeatedly, and repeatedly lost them. Looking backward now, the world after dinosaurs begins to feel less like the rise of modern life, and more like another chapter in Earth's endless cycle of experimentation. Different groups inherited dominance at different times, but permanence never lasted. Mammals replaced dinosaurs, yet many giant mammals eventually vanished too. Entire ecosystems flourished briefly before disappearing into fossil layers beneath future landscapes. And perhaps that is what makes this age feel so strangely emotional compared to earlier chapters of Earth's history. Because by now, the planet was beginning to look more familiar. Forests resembled modern woodlands in some regions. Mammals behaved in ways humans instinctively recognize. Oceans contained whales, sharks, and marine ecosystems that no longer feel completely alien. The Earth was moving toward a world where humans could eventually survive. Yet it still remained a place of enormous predators, endless wilderness, and giant animals now lost forever. There were no cities anywhere, no roads crossing frozen plains, no engines, lights, or artificial sounds. Mammoths moved through snowstorms beneath untouched skies, while giant cats watched from tall grasses. Whales crossed oceans older than human memory, while enormous birds hunted across forgotten continents. And somewhere within that immense, untamed world, one small primate lineage had already begun evolving quietly in Africa, still unaware that the age of giants around it was slowly coming to an end. For almost the entirety of Earth's history, no human eyes had ever looked at the sky. Mountains rose without names. Oceans crossed continents without maps. Forests spread across valleys untouched by roads, machines, or memory. And then, after billions of years of fire, ice, extinction, evolution, and survival, the planet approached one of the strangest moments in its entire existence. The final age before humanity appeared. It is difficult to imagine because the Earth at that point already looked astonishingly alive and familiar in many ways. Forests covered enormous regions of the world. Rivers moved through landscapes recognizable as mountains, plains, coastlines, and deserts. Mammals ruled much of the land. Birds crossed the skies. Whales traveled through deep oceans, beneath storms almost identical to modern storms. Yet, despite all this familiarity, something essential was still missing. There were no cities anywhere on the planet, no language, no fires burning intentionally at night, no music, no ships crossing the seas, no stories. Earth had become a fully living world, but not yet a human world. And perhaps that is what makes this final prehistoric chapter feel so haunting. It was a complete planet, existing entirely without us, only moments before our arrival in geological time If you could stand somewhere on Earth during those distant ages, just before early humans emerged, the silence would probably feel overwhelming at first. Not because the world lacked sound, but because none of the sounds came from civilization. Wind moved through forests, uninterrupted by engines. Ice cracked across glacial landscapes beneath pale skies. Waves struck untouched coastlines where no harbor had ever existed. At night, darkness covered the earth almost completely, except for moonlight, stars, lightning, volcanoes, and occasional wildfires ignited naturally. Modern humans rarely experience true planetary darkness anymore. But before humanity spread across the world, night itself may have felt far deeper and larger than anything modern civilization remembers. And the animals living during that time still ruled enormous wildernesses beyond anything left on Earth now. Mammoths crossed cold northern grasslands in herds beneath Ice Age skies. Giant bison moved across open plains. Saber-toothed cats hunted through forests and grasslands where prey animals had evolved alongside predators for thousands of generations. In Australia, giant marsupials wandered ancient environments unlike anywhere else on Earth. In South America, strange mammals descended from isolated evolutionary histories still survived in ecosystems untouched by modern industry. Even relatively recent Earth would feel shockingly wild to modern humans, yet climate itself remained unstable. The world approaching humanity's arrival was shaped heavily by repeating ice ages. Massive glaciers expanded and retreated across continents over cycles lasting tens of thousands of years. Sea levels rose and fell dramatically as water became trapped inside enormous ice sheets or returned to the oceans during warmer periods. Entire land bridges appeared temporarily between continents before vanishing again beneath rising seas. Humans would eventually use some of those exposed regions to migrate across the world. But before that happened, the planet itself was still shifting continuously beneath changing climates. The coastlines modern civilization recognizes today often did not exist yet. Large parts of northern Europe and North America lay beneath thick ice during colder periods. Deserts expanded and contracted. Forests advanced and retreated, with changing rainfall and temperature patterns. Earth was alive, but it remained deeply dynamic. Some scientists believe these unstable climates may have played an important role in shaping early human evolution itself. Environmental unpredictability favors adaptability. Species surviving under changing conditions often evolve flexibility, problem-solving abilities, and social cooperation more rapidly than species living in stable environments. It is impossible to know exactly how much Ice Age pressures influenced human intelligence, migration, or survival strategies, but the possibility changes how the final prehistoric Earth feels. The planet was not simply waiting passively for humans to appear. It may have actively shaped the conditions that produced them. And meanwhile, in parts of Africa, small populations of upright primates were already beginning to diverge slowly from other apes. The earliest human ancestors did not appear suddenly as fully modern people stepping into the world. Evolution moved gradually through countless generations. Different hominin species emerged, adapted, and vanished over immense periods of time. Some walked upright but retained smaller brains. Others developed tool use, social cooperation, or increasingly complex behaviors. Many human relatives disappeared entirely before modern humans evolved. The story of humanity is not a straight line. It is a branching tree filled with extinct cousins, failed populations, and evolutionary experiments lost to time. Yet, during most of that process, the Earth still remained overwhelmingly non-human. Early hominins occupied tiny regions compared to the scale of the planet itself. Vast wildernesses stretched untouched beyond their range. Entire continents remained completely unaware that a species capable of eventually reshaping the biosphere was beginning to emerge. And perhaps the strangest part is how ordinary those early humans might have seemed at first. They were not rulers of Earth yet. They possessed no agriculture, no cities, no metal tools, no written language. Predators still hunted them. Climate still controlled survival. Lightning, drought, disease, and cold remained overwhelming forces. The world belonged far more to mammoths, giant cats, forests, oceans, and weather than it did to humans. Looking backward now, it becomes clear how recently civilization arrived. For nearly all of human existence, people themselves lived inside a prehistoric Earth, far closer to ancient wilderness than modern life. But even before humanity spread outward, subtle changes may already have been beginning across ecosystems. Some scientists debate whether early human hunting contributed to the disappearance of certain megafauna populations in specific regions. Others argue climate shifts played the dominant role, while humans acted only as additional pressure on already stressed species. The truth may differ depending on location and timing. Some giant animals survived major climate changes for thousands of years before humans arrived. Others vanished surprisingly soon after human expansion into isolated ecosystems. There may never be one universal explanation. Yet, regardless of the exact causes, the world of giant mammals gradually faded. Mammoths disappeared. Saber-toothed cats vanished. Giant ground sloths died out. Entire ecosystems transformed. And as those giants vanished, the human world expanded. Fires appeared intentionally across landscapes. Hunting strategies grew more advanced. Language likely became increasingly sophisticated. Knowledge passed between generations more efficiently. The Earth was approaching a threshold it had never crossed before. A species capable not only of surviving within ecosystems, but of consciously reshaping them. Yet, in those final moments before humanity fully emerged, the world still carried a kind of ancient balance, difficult to imagine now. Rivers followed paths unchanged for thousands of years. Animal migrations crossed continents uninterrupted by fences, highways, or cities. Forests stretched for immense distances beneath skies untouched by aircraft or pollution. Coral reefs thrived in oceans no industrial fishing fleets had ever entered. The natural world was not peaceful. Predation, starvation, storms, disease, and extinction still existed everywhere, but it remained overwhelmingly wild. No species had yet dominated the planet the way humans eventually would. And perhaps that is what makes this final prehistoric Earth feel so emotionally distant and strangely beautiful at the same time. It was the last version of the planet shaped almost entirely without human influence. Every age before it had already disappeared into extinction, climate collapse, or evolutionary transformation. Dinosaurs vanished. Giant insects vanished. Ancient marine monsters vanished. Entire forests and frozen worlds disappeared into geological memory. But this final Earth before humanity still carried echoes of all those earlier ages hidden beneath its surface. Coal buried beneath forests, fossils beneath mountains, ancient ocean floors lifted into deserts. The whole history of the planet remained layered invisibly beneath the feet of creatures still unaware that one species among them would eventually uncover the story. And somewhere during those long Ice Age nights, beneath stars shining over untouched continents, early humans began looking upward with something no earlier creature had fully possessed before: awareness of the world itself. Not just survival, not instinct alone. Curiosity, questions, memory, imagination. The Earth had spent billions of years shaping oceans, forests, climates, extinctions, and life forms of every kind. But only now, near the very end of that enormous timeline, did the planet produce a creature capable of wondering what the world had looked like before it arrived. Thanks for spending this time with me tonight on Sleepy Earth Channel. If you enjoyed this journey into ancient Earth, don't forget to subscribe and leave a comment telling me what topic you'd like to explore next. Wishing you a peaceful night, good luck, and sweet dreams wherever you are in the world tonight.